All right, let's dive in. Today, we're going to pull back the curtain on the hidden rules that run, well, pretty much everything, from your social network all the way to the code on your phone. We're talking about two fundamental ideas in math, relations and functions. Now, I know they sound kind of complex, but trust me, they're really just a super precise way of talking about how things are connected. So here's the game plan for today. We're going to start with the absolute basics. What even is a relation? Then we'll look at the three key rules that give it its personality. After that, we'll meet the gold standard of relations. It's called an equivalence relation. And from there, we'll jump into its much more disciplined cousin, the function, and check out its two main flavors.
Okay, let's get right into it. When you and I talk about a relationship, it can mean a lot of different things, right? It's kind of a fuzzy idea. Well, what math does is it takes that fuzzy idea of a connection and gives it a crystal clear, super precise definition.
So imagine you see a couple of pairs of numbers, like 2, 1 and 3, 4. What's the story here? Is there some hidden rule connecting them? Is there a link? Well, the tool that mathematicians use to define and explore exactly that kind of connection, that's what we call a relation.
So, how do we actually build one of these things? It's like a simple recipe. Step 1, you start with two sets of stuff. Let's say numbers for now. Step 2, you imagine making every single possible pair you can, grabbing one from the first set and one from the second. This giant universe of all possible pairs has a fancy name, the Cartesian product. And a relation, it's just any group of pairs you decide to pick from that giant collection. That's it. You can pick all of them, just a few of them, or even none of them. Any selection is a relation.
Okay, so we've picked our pairs, we have a relation, now what? How do we talk about it? Well, we can describe its character using three key rules. You can almost think of them like personality traits for our relation.
First up, we have what's called the reflexive property. It's a really simple but super strict rule. A relation is reflexive if and only if every single element in the set is related back to itself. So if you have an element A, the pair A, A has to be in your collection. If even one is missing, nope, it fails the test.
A great way to think about this is the mirror test. It's the perfect analogy. For a relation to be reflexive, it's like every element has to be able to look into a mirror and see itself. So if your set is 1, 2, 3, you absolutely must have the pairs 1, 1, 2, 2, and 3, 3 in your relation.
All right, next up is the symmetric rule. This one is all about mutuality, about the relationship going both ways. It's simple. If your relation says that A is connected to B, then for it to be symmetric, it has to also say that B is connected right back to A.
Just think of it like a two-way street. It's that simple. In a symmetric relation, you won't find any one-way roads or dead ends. If you can drive from point A to point B, you've got to be able to drive right back from B to A.
And that brings us to our third and final rule, transitivity. This one is all about making logical chains, or maybe creating shortcuts. It basically says that if you have a link from A to B, and you have another link from B to C, then a transitive relation will always have a direct link from A all the way to C.
You've probably heard this one before. It's the friend of a friend principle. If A is friends with B and B is friends with C, does that automatically make A friends with C? Well, in a transitive relation, the answer is always yes. It guarantees that connection, linking the very start of a chain directly to the very end.
So, let's just do a quick recap. We've got reflexive, symmetric, and transitive. And these aren't just, some random abstract tests. They are the fundamental tools we use to classify and really understand the deep structure of any relationship we're looking at.
Okay, now this is where things get really interesting and really powerful. What do you think happens when a relation has all three of those personality traits we just talked about? Well, we get something incredibly useful. We get what's called an equivalence relation.
And that's pretty much the formal definition right there. When a relation checks all three boxes, it's reflexive, it's symmetric, and it's transitive, it earns the special title of an equivalence relation. You can think of this as the gold standard of relationships because it behaves in a way that's very, very similar to our everyday idea of equality.
So why should you care about this? What's the big deal? Well, the whole point of an equivalence relation is to sort things. It's a master organizer. It's the logic behind how your email client groups all the replies to a single conversation together. It's how an online store sorts thousands of products into neat categories. It takes a huge, messy pile of stuff and perfectly partitions it into these nice, neat little groups where everything inside a group is, in some fundamental way, the same as everything else in that group.
Okay, with that solid foundation in place, we are ready to tackle one of the most important ideas in all of mathematics. Seriously, let's welcome to the stage the function. And at its heart, a function is really just a special, much more disciplined kind of relation.
So always remember, every single function is still a relation. But, and this is a big but, to earn the title of function, it has to play by two extra, very strict, non-negotiable rules.
So what are these rules? Here they are. Rule number 1. Every single element in your starting set must be used. It has to be connected to something. No one gets left behind on the starting line. Everyone participates. Rule number 2, and this is the big one. Each element in that starting set can only be connected to one and only one element in the destination set. No double dipping. That's an absolute no-go.
And that right there is the key difference. A relation can be, a bit of a free-for-all. It can be a tangled mess of connections going everywhere. But a function? Oh no. A function is predictable, it's reliable, it's orderly. For every one thing you put in, you get exactly one thing out, every single time. That's the discipline that sets them apart. So yeah, all functions are relations, but only the most well-behaved, orderly relations get to call themselves a function.
But wait, there's more. We can actually get even more specific with functions. By looking at exactly how they pair things up, we can sort them into two really important types, what we call one-to-one and onto.
Okay, so what does it mean for a function to be one-to-one? Think of it as being exclusive. It means that every single output, every result, comes from one and only one unique input. You can't have two different starting points leading to the exact same destination. No sharing partners on the other side.
And what about an onto function? Well, if one-to-one is about being exclusive, onto is about being comprehensive. It means that every single possible element in the destination set gets hit. It's somebody's partner. No one on the receiving end is left out in the cold. The function literally covers all the bases. So when you're looking at any function, you can basically ask it these two simple questions. Hey, are you one-to-one? And are you onto? And if you get a yes for both, if it's both one-to-one and onto, then it gets a special name. We call it bijective, and that is the perfect matchup, a perfect one-to-one correspondence between two sets. It's like having a unique key for every single lock.
And there you have it. That's our journey through the world of relations and functions. It's amazing, isn't it? We started with just this simple idea of pairing up numbers, and we ended up with a framework that's the backbone of computer science, social networks, and so much more. It really makes you stop and think, doesn't it? What other hidden structures are out there quietly running your world, all based on just a few simple rules?